Okay, on this lesson we're going to be looking at multiple representations of different types of functions using the transformations that we've been talking about. So if we look at our transformed equation here, notice it does tell us that we are starting with our parent function f of x equals absolute value of x, and we are going to use the table to fill in, and then we're going to graph it and then also answer some more questions. So first thing that I'm going to do is just write the verbal description. So looking at it, we have a negative here, which means there's a reflection over the x-axis. And then inside, remember, is always the opposite, so we're going to be going right 3. And then the outside, we're adjusting our y, so we're going up 7. So those are our transformations. So notice we're given a table here for f. Remember, f is the absolute value of x, and we're given some x values. We're going to plug them in to find what y is. So notice they're not the same as what we used on the last couple of lessons, but we can easily plug them in. Absolute value of -6 is 6. Absolute value of -3 is 3. Absolute value of 0, 0, 3, 3, and 6, 6. So those are the points that we're going to be using for our f of x equation, so our parent function. So go ahead and plot them. So that's my parent function f of x equals absolute value of x. Now we're going to adjust our values based on our transformations. So if you remember, we talked about that on the first lesson in Unit 2. So this negative piece, we're multiplying the y's by -1. So I'm going to put multiply by -1. And then remember the inside piece, we're doing the opposite, show our x values, so we're going to add 3 to our x's. And then the +7 on the outside, we adjust our y, so we're going to be adding 7 after we multiply. So we're having to do a couple of things. Let's start with our x. We're adding 3 to all of these. So that would be -3, that would be 0, that would be 3, 6, and 9. So there's your x values. Okay, so then now let's look at our y. So we're going to first multiply by -1. Remember, that just changed the sign. So I'm going to go ahead and go through and change the signs on all of these because we're multiplying by -1. Then I'm going to add 7 now. So that's going to be a 1. That's going to be a 4, 7, 4, and 1. So those are my points that I'm going to plot for my h function. So 1, 4, 0, 4, 3, 7, 'I did not plot that. Let's go back. So let's replot these. So -3, 1. I don't know what I did. 0, 4, 3, 7, 6, 4, and 9, 1. So there's my function g. All right, so there's my, sorry, let me go back. right, so we're going to find the domain and range of f. F is the first one, the parent function. So the domain, if you look at the x-axis, the domain of the purple one is arrows going both directions, so negative infinity to infinity, or all real numbers. And then the range, looking at the y-axis of the purple one, notice it includes 0 and it's everything above it. So we're going from 0 to infinity. It does include 0, so we need to bracket and then close our parentheses on the infinity sign. Okay, so now I'm going to find the domain of h, which was our new one. So the domain is going to be negative infinity to infinity. By the way, anytime we have an absolute value, it's always going to be continuous to the left and right. So your domain of any absolute value should be negative infinity to infinity. The range, so go to your y, go to the bottom, it's arrows, so negative infinity, and go all the way up to the top. It stops at 1, 2, 3, 4, 5, 6, 7. So, and it does include 7. So there's our domain and range of h. Now we're going to describe the transformation in terms of f of x, which means it wants you to write your function. So I'm going to do h of x equals. So I know I need a negative. Look back at this. It's going to look very similar to this. I have a negative. I have f. Parentheses inside the bars is x minus 3. So that's what goes inside the parentheses. And then the plus 7 goes on the outside. So notice that's very similar to what's here. But instead of putting the absolute value of x, you're putting f of x. Okay, so that was an example referring back to our absolute value of x. Now we're going to switch over to a different type of function. Now, anytime we have, no matter what function we have, we're always going to have the same transformations. So I'm going to start out like I did on the last one, and I'm going to start with a verbal description. So notice this is linear, and it tells us we are starting with our parent function for linear, which is f of x equals x. So the verbal description is going to be very similar to what we had on the last one. The negative in front will reflect it over the x-axis. Oh boy. And then inside the parentheses is just like inside the bars. So it's going to be the opposite. We're going to go right 3. And then the outside, we're adjusting our y, we're going up 7. Okay, so we want to fill in our table. This time our f of x is not absolute value of x, it's just x. So when I plug it in, I just get negative 6. If I plug in negative 3, I just get negative 3, 0, 3, 6. So let's go ahead and plot our parent function, f of x equals x, the linear parent function. You should already know what this looks like because remember we talked about this first off on the parent functions, but also on the inverses. Remember that was a reflection across the y equals x line. So there's f of x. And now we're going to find j of x. They're using different letters. All means the same stuff. So using our transformations, we're going to adjust our parent function table. So remember the negative in front will multiply the y's by -1. So remember that changes the sign. So I'm going to go ahead and do that. And then the inside, we're going to be going right 3, which is adding 3 to our x's. And then the plus 7, we're adding 7 to our y's. So add 7 to the number that you changed after you multiplied it by -1. All right, so my new x's, -6 plus 3 is a -3. Negative 3 plus 3 is 0. 0 plus 3 is 3. 3 plus 3 is 6. And then 9 there. Our y values, so remember we had to multiply by negative 1, so we're looking at positive 6 plus 7, which would be 13. Positive 3 plus 7, which is 10. 0 plus 7 is 7. Negative 3 plus 7 is 4. And negative 6 plus 7 is 1. Okay, so now let's plot those points and see what our J will look like on the graph. Negative 3, 13 clearly goes off the graph. We're not going to be able to plot that one. 0, 10. Okay, so there is 10 there, so that's up there. And then 3, 7. 6, 4. And 9, 1. So this is our J of X. All right, so we used the same transformations as we did on the absolute value. This works for every type of function. The negative will reflect over the x-axis and all the other stuff. So everything is the same no matter what function you have. All right, so we're going to find the domain and range of f, which is our pink one here. So domain, if you look at the x-axis, it's continuous all directions, so negative infinity to infinity, or all real numbers. And then notice the range will be the same because it's also going up, keeps going, and continuously going down, so negative infinity to infinity. Anytime we have linear, there's arrows at both ends going left, right, up, down, so you should be having all real numbers for both, or negative infinity to infinity on any linear equation. So that should help you with finding your domain and range of J. Negative infinity to infinity, and the range is the same because it's continuous all directions, it never stops. Okay, so now we're going to describe our transformation using f of x. So I'm going to start out with J of x because that's what it was called over here. Remember, look over here. Look at that equation, it's very similar. So I'm going to have a negative, but instead of just the parenthesis, I'm going to put f, and then inside the parenthesis I need x minus 3, and then the outside I need plus 7. So it looks very similar. It's just using function notation instead, referring back to your f of x equals x. All right, let's take a look at the back. So notice this time we're going to be looking at quadratic. So it tells you your parent function f of x equals x squared. All right, so we're going to go ahead and start with our verbal description. So notice we have a negative in front. It reflects it over the x-axis. The x minus 3 inside will be going to the right 3, and then up 7. Okay, so my f of x is on this one x squared. So we're going to plug in these values. Negative 6 times a negative 6 is a positive 36. Anytime you're squaring something, it should always be positive. Negative 3 times a negative 3 is 9. So if you happen to plug it into the calculator, you must put parentheses around the negative 3 before you square it. 0 times 0 is 0. 3 times 3 is 9. 6 times 6 is 36. There's my points. We clearly will not be able to graph the negative 6, 36. So we'll move on to negative 3, 9. 0, 0. And 3, 9. So there's my function f, my parent function. And then we are going to do just our table values. So remember, the negative in front multiplies your y by negative, which will just change the sign. Then we'll add 3 to x, and then we will add 7 to our new y after we multiplied it by negative 1. So I have a -3 for my x, and then I have a -29 for my y. That will be 0, and then I have a -2. Then I have 3 and 7, 6 and -2, and 9 and -29. Okay, so clearly we won't be able to graph the -3, -29, so we'll go to 0, -2, 3, 7, 6, -2, and then we can't graph the other one, so this is our K. Okay, so we want to find the domain and range of f. So domain, if you look, it's continuous left and right, so -infinity to infinity. Your range, go to your y-axis, go to the bottom, it stops at 0, and then it goes up to infinity. Looking at the pink one, the K one, so domain, -infinity to infinity. It will be the same for any parabola that we have because it will be continuous to the left and right. The range, go to the bottom. Notice there's arrows at the bottom, so -infinity. Go up to the top of the y-axis, and that's at 7. Okay, so we found the domain and range. Now we're going to look at the function notation f of x. So again, it's very similar to this. So I'll start out with k of x equals, and then I'm going to have a negative in front, x minus 3 inside parentheses, and then the plus 7. Now notice here we're not putting the squared, and we didn't put the absolute value bars on the absolute value one. So you should not be putting whatever is in your original parent function. So you're just using f of x. Okay, so notice it happens the same way. All your transformations are the same no matter what type of function you have. If you have any questions, let me know.